This lecture explains what an encounter is, how we use algorithms to determine the behavior of characters in encounters, the personality model behind those algorithms, and finally, the mathematical system used by the algorithms. An encounter consists of 4 parts. The first part is an introductory text presenting the player with a dramatically interesting conundrum. The second part is a list of options available to the player. For each of these options, you must define the emotional reaction of the antagonist to the player's choice. The fourth part consists of the outward response of the antagonist to the player's choice. This will depend on the personality of the antagonist and the algorithms that you create. The first concept is that of a personality model. I described my personality model in the previous lecture. You will recall that it uses 3 basic dimensions: good, honest, and powerful. We actually call them bad good, false honest, and timid powerful, because this makes clear the difference between the negative aspect of the personality trait and its positive aspect. Bad good is a measure of how nice or noble or virtuous a person is. It runs from -1, meaning really, really bad, and +1, meaning really, really good. An average person has a bad good value of 0. As you might expect, most people are somewhere in the middle of the bell curve. Only a very few people are at the extremes. Let's take some of the characters in the Matrix film trilogy as examples. The Oracle is definitely a very good person, so I'm going to put her just below +1 on the scale. Next comes Rama, the exiled program. He's a nice enough guy. I'll put him at +0.4. I figure that Mouse is right around 0. He's not bad, but he's not especially good either, so I put him down as average. The Merovingian is definitely a bad guy, but he does have a certain charm, so I'll put him at -0.5. And of course, Agent Smith is the baddest of the bad guys, so he belongs at -0.99. False honest is a measure of how likely a person is to tell the truth and deliver on promises. Again, a value of 0.0 is applied to an average person. A positive value is applied to a person who is more honest than an average person, and a negative value is applied to a person who is less honest than an average person. Timid powerful is a more difficult concept. Perhaps it's best described as strength of character. You could also use words like assertive or dominating or pushy to describe the concept. In the Matrix, Morpheus has high positive timid powerful. The kid, who's always pestering Neo, has negative timid powerful. Neo himself starts off with negative timid powerful, but shifts to the positive during the course of the story. These 3 traits define a character's personality. We extend these traits by asking a simple question: how do other people perceive the values of a character's personality traits? For example, suppose that Joe has a false honest value of +0.4. He's a pretty honest guy. But Tom doesn't know the actual value of Joe's false honest. He has only his own experience to guide him, which never shows the entire picture. So Tom's perceived value of Joe's false honest will not be the same as the actual value. In the same fashion, Anne has her own perceived value based on her own experiences with Joe, which are not the same as Tom's. We call these perceived values of a personality trait the p-values. In this case, the p false honest value is what we normally call trust. The same thing applies to the other personality traits. The perceived value is based on personal experience, and so it can often be different from the actual value. Tom might have seen Joe at his worst and therefore have a low value of P bad good for Joe. On the other hand, Anne might have seen only Joe's better side and so might perceive his bad good to be higher than it really is. The P bad good value can be thought of as affection. Obviously, this is a gross generalization of some very subtle concepts, but the important thing here isn't whether it's right or wrong, it's how useful it is in interactive storytelling. Now, I've got years of experience with this model, and I can tell you it works very well in calculating the response of characters to a given dramatic situation. These are the three basic personality traits. Their values, as perceived by others, establish the relationships between characters. Sometimes we need to use the negative values of these factors. For example, if somebody is a nasty person, then their bad-good value is less than 0, and their negative bad-good value is greater than 0. Altogether, these are the 12 factors that you can use in designing your algorithms. These 12 factors are the colors on your personality palette for painting the behavior of your characters. You blend them together to get the precise effect you want. When you combine these two numbers, you get a number we call the inclination value. Whenever a character must choose among multiple options, he always goes with the one with the highest inclination value. For example, suppose Anne has a choice between doing something nice to Joe or something nasty. It seems obvious to me that the choice should be based on two factors: how bad good Anne is and how much Anne likes Joe. Remember, we call that P bad good. So we just add these two numbers together to get the inclination to do the nice thing. And we use the opposite of these numbers, the negative of their values, to get the inclination to do the nasty thing. Let's try some specific numbers. Let's suppose that Anne is a really bad person with a bad good of minus 0.7, but she really likes Joe with plus 0.5. Those two numbers add up to minus 0.2, which is still negative, and so she's going to do the nasty thing. On the other hand, if she's not quite so bad, minus 0.3, and she likes Joe even more, plus 0.6, those numbers add up to a plus 0.3, and she's going to do the nice thing. If she's a fairly nice person, plus 0.2, and kind of likes Joe a little bit, plus 0.1, again, those numbers add up to 0.3, and she'll do the nice thing. But even if she's a really nice person at plus 0.5, if she hates Joe with minus 0.6, those numbers add up to minus 0.1, and she's going to end up doing the nasty thing. So that's the basic idea about how you use personality traits to direct the characters to make decisions. There are 3 steps required to pull it off. First, you select the 2 most relevant personality factors. Next, you combine them to get the inclination. And lastly, the character chooses the option with the highest inclination. The mathematical system we use for interactive storytelling is based on years of experience. It's kind of strange. We use something called bounded numbers. These are numbers that are constrained to fall between -1 and +1. The mathematical system is rigged so that no matter what happens, the numbers can never go out of bounds. Our bounded number system has its own mathematics. For example, we have what we call bounded sum. You can add 2 numbers together, but no matter what, the result will always be less than 1. For example, the bounded sum, or B-sum as we call it,
of 0.5 and 0.75 is only 0.8.
Okay, so you're asking, why do we use such a screwball system?
It all comes from the personality model. In that model, we assume that people have a bell curve distribution of any personality trait. Most people are in the middle, and there are some people who are better or worse than average. But nobody is ever perfectly good, that is, with a value of +1, or perfectly bad, with a value of -1. Remember, that bell curve also describes the relationships between people. For example, John has an intrinsic value of bad good, but Anne's perceived value of John's bad good is how much she likes him. Now suppose that John wants to win Anne's heart, so he gives her flowers. This causes her to like him more. Her perceived bad good value for him increases. Now, obviously, giving Anne flowers doesn't cause her to fall in love with John, but it does increase her affection for him slightly. Let's say that giving Anne flowers causes her to like John more by, say 0.01. That seems entirely reasonable, doesn't it? Here's the flaw with that thinking. John just keeps giving her flowers over and over, and pretty soon, ta-da! You see how useful mathematics can be?
Bounded sums prevent this kind of thing from happening. But the most powerful trick with bounded numbers is the blend operator. It's simple enough. It simply blends two numbers together in proportion to a weighting factor. You can solve almost any problem with the blend operator. It's a little weird, but it's really powerful.
Here's a really simple example of blending. Suppose that we have two numbers. The simplest possible blending is to find the midpoint between them. But what if you want to put more emphasis, give more weight to the blue personality trait? Or what if you wanted it the other way around, with the red trait getting more weight? That's what blend is for. You can visualize the blending process by putting a shrunken version of the bounded number line, from -1 to +1, over the red and blue arrows. Then you put the weighting factor, the yellow arrow, on this shrunken scale. Then the green arrow, the result, simply follows the yellow arrow. So let's try this with the original example encounter I gave at the beginning of this lecture. Let's say that the player has chosen the first response, making fun of Joe. We'll need to calculate how Joe will react to the player's taunts. Joe has three choices. He will choose among them based on his own personality as well as his relationship with the player. Now let's look at each of the three options Joe has and consider how we can use his personality and his perceptions of the player to make his decision. Joe would only take the first option if he were a bad person and considered himself superior to the player. So we know what factors to use for his first option: the negative of his bad good value and the negative of his p timid powerful value towards the player. I would think that Joe would choose the second option if he likes the player and is a bit timid. That means that we'll use p bad good and minus timid powerful. And Joe would ignore the player if he considers him insignificant scum and or dislikes him.
Now, you're probably asking, how did I know which factors to use? Well, I don't. But I believe these factors to be the best ones based on my personal assessment of human nature. This is where I express my artistic perceptions. This is how you do the art.
Yeah, I know the objection. You can't reduce people to numbers. That's sacrilege. People are too complicated to be reduced to mere numbers. But the very essence of art is to strip away details, to expose the deepest truths. Is it sacrilege to reduce Mr. Obama's picture from 16 million colors to a few hundred? A few dozen? 6? 4? 2? What some people call reductionism, I call art.
Math is a medium of expression, just like images, music, or language. And true, it doesn't have a heritage stretching back thousands of years. That's because computers are new. But do you want to spend your life in old artistic media competing against the likes of Aeschylus, Michelangelo, Beethoven, and Hitchcock? Or do you want to be a pioneer in a new artistic medium?
Let me show you how it's done. Let's return to our example with Joe. We've decided that we'll use Joe's bad good value and his P timid powerful value towards the player to decide whether he'll take option number 1. Here's how we'll use blend. First, let's make up some values for the two factors at work. We'll put his P timid powerful value at, minus 0.6. In other words, Joe thinks that the player is a really timid guy. And let's put Joe's bad good value at minus 0.4. Oops, we have to use the negative of his bad good value. There, that's better. Okay, I'm going to use a weighting factor of 0.5. This yields a final result of 0.1. Let's try something else. Let's suppose that somebody other than our player had made fun of Joe. Suppose further that Joe is really intimidated by this new character. Then the blend operation would look like this. Note how we reversed the little ruler. That's because the blend always starts at the same factor. Let's compare the two different calculations. In each case, the +1 side of the little ruler sticks to the purple arrow, and the -1 side of the ruler sticks with the red arrow. Here's a little animation that gives you another way to visualize how blend works. This shows how it reacts when you change the weighting factor. Now let's see how it changes as we move the blue value.
The blend option may seem weird at first, but it's really useful. Just pick the two factors most likely to affect a character's decision to select that option, blend them together, and then put more or less weight on one of the two factors. That's all it takes to equip your characters with the ability to make dramatically interesting decisions. With a little practice, it's really quite easy.